one of the issues we had to overcome was that Amana Goodman has done a fairly successful job at telling dealers that they have a better design because of a few things that they say are better. One of them is the tubular heat exchanger. Okay, the tubular heat exchanger has a very limited amount of surface area. It's smaller, it's more constricting. Okay, the flue gases that are developed in the combustion process can't remain in that heat exchanger very long, otherwise it'll burn up. So in order to move the products of combustion through a tubular heat exchanger, you need more fan velocity, okay? And when you introduce more fan velocity, what else do you introduce?
Noise.
Noise, exactly. Now just to look at this fan, you can tell by the design of this fan, it's much larger. It probably has a little different horsepower rating. Trane uses what's called a low energy fan, okay? A couple of reasons. First of all, we don't need the velocity, we don't need the volume to pull the products of combustion through our heat exchangers, because our heat exchangers are much larger, they have much more surface area to exchange the heat onto the primary heat exchanger, and the gases can spend a little bit longer time in there in order to make it more efficient. Tubular heat exchanger, if the gases spent too long a time in there, it would burn it up. Okay, so if I had one of these heat exchangers out here, you could see all the surface areas, the S-curve design.
Right, and then there's the webbing between it.
Right. Plus, we use it's a two-piece heat exchanger that's put together with it's a rolled, crimped design. There are no welds, there are no stress points in the metal, because when when the metals heat and cool, the stress areas are what'll crack first. Okay, so but to further the advantage of having a low energy venter, okay, because we don't need all that velocity, we don't need that volume to go through the system. Our low energy venter is rated at 1.0 amps. The competitor is 2.8 amps, okay, which tells us there's more horsepower required to move the products of combustion through the tight heat exchanger, okay, and there'll be more noise and it uses more energy. While we're on the subject of horsepower and energy, okay, due to the design of this system, we believe that the smallest blower that can be used in conjunction with this design is rated at 3 tons, or 1200 CFM maximum. Our horsepower, okay, is much less, because we can operate the system efficiently with 800 CFM for our maximum, and we can go as low as 540 CFM. So that's, critical as far as if we're trying to save energy, trying to reduce noise. The Trane uses, we're the only one in the industry that uses a patented in-shot burner with a diffuser that's integral to the construction of the burner. All of our burners are 20,000 BTUs maximum orifice. The competitive unit is 22,500, more BTUs, more noise. Okay. What we do is you only use multiples of 20,000 BTUs burners with each heat exchanger baffle. So we'll have 20, 40, 60, 80, 120, up to 140,000 BTUs in some sizes. The noise that's generated by one burner, okay, is the loudest that can be heard when the system is operating. You do not accumulate decibels as you introduce burners. So the smaller the burner, the lower the noise. Competitor is a larger burner, more noise. Larger burner, more combustion noise. Higher velocity fan, more fan noise. Another big difference between Trane and competition. Our low-end furnace, which is TUC, uses silicon carbide. This silicon carbide design has been used for about 15 years. We've used adaptive technology in our ignition controls. We prolong the life of these, but it's still potentially a weak link in the system, okay, because it is silicon carbide. But you can tell by the mass and the amount of surface that's on that we could probably last a while in many cycles. Goodman uses silicon carbide, but take a look at the mass.
Silicon carbide?
That's silicon carbide, okay. Take a look at the mass on that igniter compared to the mass on our silicon
Right.
carbide igniter, okay? Both of them are very fragile, but my suspect is this will be a lot more fragile, and due to the cycles that the furnaces will have to endure, that this wouldn't last anywhere near as long as that one.
Right.
Okay. Plus, the technician who's servicing the unit runs the risk of having to, could potentially break that during service.
Right.
It's installed below the burners. So, on the TUX model, okay, our upgrade model, we use silicon nitride. Silicon nitride, much more durable. We use adaptive technology where we actually manage the voltage that goes to the igniter with every cycle, and we try to minimize that voltage to prolong the life of the silicon nitride igniter. So there's a huge advantage as far as reliability and longevity of the igniter. When we look at how our burner boxes are designed, all the Train 90 Plus models uses an isolated combustion by virtue of a burner box, okay? We have a true sealed combustion chamber where we have outside air with an intake screen and exhaust air from the inducer. Our door, it can be used to protect the consumers from exposed parts, but in the upgrade model, the door actually becomes a solid door, and it will further minimize noise from the inducer, okay? So the upgrade model has a solid door. Competition uses a solid door, but by virtue of the solid door, that's how they make this a sealed combustion unit. However, if you look at it, on the intake, there's no intake screen. There's nothing that would prevent condensation or moisture that comes to the intake from contaminating all of the working components of the furnace.
And other debris.
Or debris, right? Leaves, birds, bees, you name it. So, and the door actually is what accommodates it to a sealed combustion design, completely different from what we're doing with our advanced design. So,
And you got a screw on rather than.
the door has some flimsy gaskets on here. It's actually a flimsy door. Has a crinkle finish, which to me just gives it a much cheaper look. The other feature that we have is it's really an installability feature for the dealer. All of our furnaces come with the trap assembly assembled and a ready-made and ready-to-install connector pipe. Comes complete with the clamp and a PVC adapter to adapt to a common PVC drain. All we have to do is use the knockout at either side of the furnace if we're going to go on the right side or the left side. Goodman uses, basically it's a very inconvenient built-up system. The drain on the high-efficiency coil is not connected to anything. You actually have to read the instructions, assemble it. There appears to be about 15 parts or so in this kit. So we have to somehow configure all the components of the kit, install them. There's these clamps that I'm not too sure what they're for, but you'd have to configure it, and it's just going to take more time to assemble all that and do the job correctly. So this looks like a real inconvenient way to configure the drain. A lot of potential for errors and problems. This is a real flimsy rubber hose.
You gotta cut that to length.
Yeah. So nothing like the quality of the materials that we use with our pre-assembled drain. I just want to point out that the competition does not use an insulated blower cabinet. Okay. And by the way, the cabinet itself, this is 3 pieces of sheet metal that's screwed together. Not very rigid. The unit wobbles. There's a lot of opportunity for vibration, and where Trane uses a 1-piece pre-painted bonded steel sheet, folds it, and makes it into 1 piece, much more solid, even a lot heavier than competition. In the TUX upgrade model, the retail model, we are insulated on all 4 sides of the blower compartment, and we use, there's the insulation, and we use an automotive type, gasketed seal, which actually has an air cushion in it, so it seals nice and tight. And with our latch assemblies, okay, we have an easy to assemble, easy to remove blower door assembly. And these latches are really convenient. Matter of fact, our dealers tell us they love these units with the latches on because it makes service a lot easier, and they don't have to worry about cutting their hands. Some applications where the consumer actually has to change the filter, makes it a lot more convenient if the filter were installed inside the furnace. Most of the applications we do today, though, it's exterior. We have HUM and EAC terminals already pre-wired and tagged accordingly. We can power our humidifier transformer and power our electronic air cleaner right off of these that are all pre-wired and ready to go. They actually ship you a wire, and it's pretty complicated procedure. It says the yellow wire connected to the ID blower pressure switch is powered whenever the pressure switch is closed and provides 24-volt humidifier control. Remove the yellow wire and connect the supplied brown jumper wire to the pressure switch terminal. Reconnect the yellow wire to the piggyback terminal on the brown jumper, and then connect the 24-volt line of the humidifier to the stripped end of the brown wire. This connection can be made using a wire nut or by using field-supplied quick connect terminal. The wiring must conform to all local and national codes. So on. Just another inconvenient way of adapting the unit to a normal application. This particular unit was shipped to us in a brand new wrapper, which by the way was a plastic bag with shipping straps on it, on a wooden pallet. Trane ships theirs with multiple layered cardboard, 100% cardboard. Comes with the rubber shipping feet that keep the bottom of the furnace from being damaged. Sometimes these are even used to support the furnace during installation. This furnace, when we opened it, we inspected it to see if there were any obvious defects, and lo and behold, we had a defect in the recuperative cell, the secondary heat exchanger. Trane tests every furnace before it leaves the factory. At the end of the assembly line, they put it on a turntable, they hook it up to a vent system, they hook it up to gas, they hook it up to electric, and they perform, I believe it's a 16-point test.
How long is that test?
It only takes a few minutes, like 1.5 or 2 minutes.
Okay.
But they're able to check all of these, operating points. This, with that kind of defect, one of our furnaces would never have left the factory.
No.
This was packaged, opened here with a defect in the heat exchanger. All in all, I think it's pretty clear to see that the product itself it doesn't really even fit in the same category as what we're selling with Trane. There's so many design differences that you know that show us that Trane is a much superior piece of equipment. And be frank with you, if I were a professional dealer, I would be embarrassed to install that piece of equipment knowing that I could install one of these.